Algebra 1 kids, this is Dr. Callahan with week 8, Wednesday. So go ahead and pause the video and copy this part down in your warm-up log. All right, let's go ahead and proceed forward. Let's take a look at the first question that we have here. So the first thing to do is you notice that there's a -3 on the outside of your parentheses. So you're going to take that -3 and multiply it into the parenthesis, and that's called the distributive property. So -6x minus 18 equals 12. Next, you want to isolate the x by itself, so you want to get rid of the 18. Opposite of a -18 is a positive 18. So you bring down the -6, positive 18, -18 cancels. You have a 30. Now to get rid of the -6, you want to divide by -6 on both sides. X is equal to -5. And that is your answer. If you'd like to check your answer, you can always go ahead and do 2 times -5 plus 6 and see if that equals 12. Well, let's see. 2 times -5 is a -10. -10 plus 6 is a -4. -3 times a -4 is a positive 12. And that's how you know if your answer is correct or incorrect. All right, I hope you guys had a wonderful week. Welcome back from fall break. And today we are going to go over, we're going to go ahead and proceed over with week 8, Wednesday. But your notes are actually going to be on week 8, Tuesday. So do not use your blue student packet, use your white packet and go to week 8, Tuesday, even though today it's Wednesday. We're going to go ahead and go over arithmetic and geometric sequencing. And this is something that we're going to go ahead and talk about today. So your notes, which again is on week 8, Tuesday, even though today is Wednesday, I get it. So today is Wednesday, is going to look like this. It is going to be a foldable, but you're not in my class right now. So you are welcome to go ahead and just copy it down on a separate piece of paper and then put it into your folder. All right, so what you're going to do is you're going to take a look at the left side of the foldable and the right side of the foldable. On the left side of the foldable is going to be on geometric sequencing. On the right side, on the left side is going to be arithmetic sequencing. Arithmetic is going to be on plus and minus. On the right side, it's geometric, which is going to be on multiply and divide. All right, so first things first. Let's take a look at an arithmetic sequence. An arithmetic sequence has a common difference. A difference means that it can either be plus or minus. The rules for arithmetic sequence is as follows. This is the formula for that. N is a term you're trying to find. A1 is always going to be the first term. And D is going to be the common difference, which is the pattern. Last time I saw you guys, we talked about ascending and descending patterns. Like you have 2, 4, 6, 8. What's the next number? You should say 10. And how do you know that? Because you know you're multiplying everything by 2. I'm sorry, you're adding everything by 2. So that plus 2 is going to be your pattern. And that's what the D is a pattern. So tell whether each sequence is arithmetic if it is stated the common difference and by the next term in the sequence. Arithmetic means that everything you're adding is either by adding a number or subtracting a number. So pause the video and take a look at A, B, C, and D. All right, so the first one, it is -7, -3, 1, 5, 9. Well, to me, it seems like you are adding 4. Negative 7 plus 4 is negative 3. Negative 3 plus 4 gives me a 1. 1 plus 4 gives me a 5. 4 plus 5 gives me a 9. 9 plus 4, and it gives me a 13. So yes, it is arithmetic because you're adding 4. And D, which is your pattern, is equal to 4, positive 4. Take a look at the next one. So from 5 to 22, it looks like you're adding 17. 17 plus 22 is 39. 39 plus 17 is 56. 56 plus 17 is 73. And so your D, which is your pattern, is plus 17. C, you're going from 8 to 9, so that's a plus 1. 9 to 11, which is a plus 2. 11 to 14, which is a plus 3. And then from here, you go to a plus 4. This right here is not an arithmetic sequencing because it does not have a common. Keyword is common. It does not have a common addition or subtraction or a common difference. So the answer is no, it's not arithmetic. All right, let's take a look at the next one. From 19 to 12, you are subtracting 7. From 12 to 5, you're subtracting 7. 5 to negative 2, you're minusing 7. Negative 2 to negative 9, minusing 7. And then negative 9 minus 7 is a negative 16. And that's your pattern. All right, let's take a look at example 2. If we were to go ahead and graph these points, remember your x value is always first, followed by your y value. You will have something that looks like this. It also represents a straight line, which means that it is a linear equation, like y equals mx plus b form. All right, let's go ahead and take a look at example 3. Write a rule for these arithmetic sequences. Remember, A1 is your starting number, D is your pattern, and then replace A1 and D with your number, okay? So A1 is pretty easy. What's your first number? Negative 11. Next, what is your pattern? Your pattern from negative 11 to 6 is that you are adding 5. From negative 6 to negative 1, you're adding 5. 1 to 4, add 5. 4 to 9, add 5. So your D is 5. Now, replace the A1 with the negative 11. Replace the D with the 5. And that's your equation. And if you ever want to know if you were to continue this pattern like 100 times, which, you're not going to add 5 100 times. I mean, that takes forever. If you want to see what the 100th term is, you put that 100 number right here for 1. So, in. 100 minus 1 is going to give me a 99. 99 times 5 is 495. But then don't forget the minus 11, which is going to give you 484. So if you're to do this plus 5 100 times, your answer is 484 on the 100th term. So this little formula is actually pretty awesome because it saves you some time. All right, take a look at B. A1 is your first number, which is 4. What is your pattern? It looks like I am adding 9 to everything. So my D is 9. Now let's go ahead and replace that. A1 is 4, D is 9. Now let's try this. If I want the 100th term, what would that be? 99 times 9, grab a calculator, is going to give you that number. That number plus the 4, because you can't forget the 4 here, is going to give you 895, which is your 100th term. I'm going to have you guys do C by yourself. What is A1? What is D? Pause the video, give that a try. And that is your answer. If you're to find a 100th term, it's negative 173. All right, now let's take a look at the right side, which is geometric sequencing. Geometric is a ratio, and that is a formula itself. So let's take a look at example 4. What is the next sequence? Here, you're either multiplying or dividing. And with dividing, you could actually use a fraction. From 2 to 8, it looks like I'm dividing by, or actually I'm timing, not dividing, timing. Timing by 4. 8 to 32 times by 4. 32 to 128 times 4. 128 times 4, 552. Your R is a pattern, and it's just multiplied by 4. Next one, here we go. 1 to 4, it looks like I am doing something different. It is not timing. I mean, 1 times 4 is 4. But how do I get from 4 to 9? And then 9 to 16? It looks like this is a 1 squared, 2 squared, 3 squared, 4 squared pattern. So is this geometric? No, because it's not a common multiplier. All right, next one, 31 to 27. It looks like I'm dividing by 3 or multiplying by 1 over 3. So what is 3 divided by 3 for the next term? It's going to be a 1. And yes, it is a geometric sequence. Next one, here we go. For this one, it looks and appears that I am dividing, but it's a negative 3. Negative 5, or I'm sorry, timing by a negative 3. Negative 5 times negative 3 is a positive 15. Positive 15 times a negative 3 is a negative 45. Negative 45 times negative 3 is a positive 135. And so the next number, negative 405 times negative 3, is a positive 1,215. And again, your R is negative 3 because you're multiplying everything by a negative 3. If I were to go ahead and graph a geometric sequence, your graph will look something like this. And it's actually like an exponential. It's not a straight line, it's kind of a curved line. The word exponential we'll go over next time in the future. All right, let's take a look at example 6. What is the rule for the geometric sequence? Your R is multiplying by 6, so your R is 6. And your A1, which is the first number, is just 2. Take a look at B. Your first number is A1. And what's your pattern? It appears that you're multiplying by 3. So replace the A1 with the number negative 5. Replace the R with a positive 3. Last one. Your first number is 81. And they're going to be dividing by 2. Or instead of a 2, it's a 1/2. So your A1 is 80. And your R is 1 over 2. All right, you guys. Well, that is basically it for arithmetic and geometric sequencing. It's not too bad, pretty simple for the most part. So now what I would like you guys to do is for your exit ticket. Today I learned blank. I didn't know blank. I don't quite understand blank. I still have a question about blank. Hashtag make up something. All right. So next, I'm gonna have you guys turn back to your guided notes. If you go ahead and go to week 8, Tuesday, for Wednesday, I know today's Wednesday, but you're gonna go to Tuesday. Go ahead and start working on this worksheet. When you're done with that, go ahead and start working on the second part. If you need some additional videos to kind of clarify this, I do have other videos right here. And then your homework is to go ahead and complete these 3 questions. Keep in mind that your class is always 55 minutes, even though you're at home, but make sure you guys are using this time wisely to fill out the pages of your white packet. All right, you guys, last page right here, you can use that as extra credit. You just need to show me in class and I will give you points for that. I hope you guys have a wonderful week and I will talk to you next time. Take care. Bye-bye.